Hi and welcome to this video on immunity and vaccination. Before watching this video, please check out the video on preventing the spread of pathogens, as it explains how normally our skin, mucus, cilia and stomach acid are brilliant at preventing pathogens from getting into our bodies. But there are times when these defences do get breached, and when they do, the pathogens are essentially in our bloodstream, and once there, they can get around our entire bodies in seconds, replicating, producing toxins, and invading our cells, making us very, very, very ill. Luckily for us, we have these white blood cells that are constantly on the prowl for invaders into our body. The way in which they recognise an invader is that they're looking for these special proteins that all cells have on their surface, called antigens. And if you liken white blood cells to Border Patrol would look for things like visas. And if somebody's got the right visa, then they belong there. So if a cell has the right antigen, then it should actually belong in the body. And every single one of your cells should have the same antigen on its surface. So your white blood cells would see those antigens and go, right, they're supposed to be here, we'll leave them alone. If something does come into your body that has different antigens, it could be a pathogen, it could be a pollen grain, it will have different antigens on its surface, it would be like a different visa, and the white blood cells would recognise that cell as being foreign, non-self, and will launch an attack. Now there are different ways in which white blood cells can launch this attack. The first way is that if they recognise a cell that's got different antigens, they will simply engulf that cell, kind of like cell eating, where the pathogen goes inside the white blood cell cytoplasm. And once inside there are these very, very powerful digestive enzymes that basically get released into the area that the pathogen is contained inside, and they break down that pathogen, rendering it harmless. Engulfing pathogens is great as a short-term fix. The only issue is that bacteria and other pathogens replicate very, very quickly. And they can either, if they're viruses, they can get inside of our cells. In the case of bacteria, they can actually produce toxins, which are poison. And a very special type of white blood cell actually works on making a protein called an antibody. So this protein gets manufactured inside these white blood cells, and an example of what one of these would look like is being drawn here. So this is an antibody, and it takes a white blood cell time to actually make this, because the antibody itself has to be able to specifically fit onto the particular shaped antigen that the particular pathogen is displaying. So that is a perfect fit. And as you can see, this antibody gets made inside the cell, then it gets released out of the cell. It can actually cause several pathogens to clump together. By fitting onto the surface antigen as well, it can actually stop the pathogens gaining entry into the host body cells. So the antibodies can work in various different ways, but in this particular illustration, the antibody is clumping together several of the pathogens, in which case you can get the white blood cell that goes around engulfing the pathogens, could engulf several pathogens at once, which is really, really good. So now these white blood cells have engulfed all of these pathogens, sort of eaten them all up, which has eradicated the pathogens from our bloodstream, but they've left all those nasty, horrible, poisonous toxins, which if we left them there, they would keep on making us ill. So there is another type of white blood cell. This type of white blood cell has a sole job of making an antidote to these toxins, which is aptly named an antitoxin. So here it goes, it's releasing those antitoxins, getting rid of all of those nasty toxins. What's also really exciting is that once these antibodies have been made, they are stored within the body. So it's like a recipe. Once it has been made and perfected so that it can fit on to the particular pathogens, antigens perfectly, it doesn't need to be made again. So when that pathogen does invade your body for a second time, your white blood cells don't have to go back to the drawing boards to redesign it. It's already made, it's already stored, so that the attack could be launched immediately and in full vigour. So if that pathogen enters your body again, these antibodies are released instantly and in much, 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 much larger quantities, so that the pathogen doesn't have a chance to replicate, doesn't have a chance to produce any toxins, and at that point you are said to be immune. So a brief summary so far of these key terms. They are often confused by students, mainly because they look and sound very, very similar, but you do need to get your head around them. So antigens are unique proteins on the surface of cells. The word antigen actually is short for antibody generators, and that's because the antibodies, which are proteins, actually bind to these antigens. And when they do, they can either damage the pathogens or clump them together. And some pathogens like bacteria produce toxins, so there are white blood cells that make antitoxins to counteract or cancel out the toxins released by these pathogens. So all in all, that covers how we develop a natural immunity to a pathogen. But there are some pathogens that produce toxins that are so disastrous to our bodies, they could be even fatal. And we would be dead or paralysed or severely damaged in the time it will take our white blood cells to make those antibodies, in which case we would need to receive a vaccination for those particular pathogens. So vaccines allow our body to generate immunity, but artificially. And the way in which they work is that you are basically getting the white blood cells that produce antibodies to do that particular job, but in response to a pathogen that isn't going to harm you. So when you get vaccinated, you are often injected with a dead or weakened version of that particular pathogen. They will still have the same surface antigens that the real nasty version of that pathogen would have, and the white blood cells would recognise those antigens as non-self and would start working on that recipe to make the correct shaped antibody. Once they've worked out the correct shaped antibody, they will release those antibodies into circulation, and if they are the right fit, they will clump those pathogens together, as mentioned before. And what's really, really good about the antibody is once it's been made and cloned, you have an archive of these, so that if you do actually get infected with the real version of that pathogen at a later date, the antibodies are there, they are released immediately, and they are released in large quantities so that they don't give that pathogen a chance to replicate or produce the toxins that could be fatal for you. Many vaccination programs work on the principle of herd immunity, which means when a large number of people in a population are immune, the incidence of the disease decreases. So here we have a graph where we've got cases of a particular disease over a time period of years. We could use the example of whooping cough disease here. All these people do not have immunity to whooping cough. So one person could get whooping cough and easily pass that illness onto this person or this person or this person. And as a result, cases of the disease are very high. They fluctuate, but they are very high. After a certain period of time, a vaccine was introduced for this particular disease. That's represented by this green line here. People would immunise their children against whooping cough, and those children will grow up with immunity, and as a result they'll be nice and happy like all these green people are in this illustration. Now, if this person contracted whooping cough, they are less likely to be in contact with another person who doesn't have immunity and pass the illness on. Instead, if they were to try and spread this illness to any of these immune people here, they simply will not contract the illness. And as a result, cases of the disease post-vaccination plummeted very, very considerably. However, with all vaccinations, there's always some sort of scare story in the media. One classic example of this was the measles, mumps and rubella vaccine, or the MMR vaccine, and this was linked by a very poor scientific study to autism, which is a developmental disability that affects how a person communicates with and relates to other people. As a result of this scare, parents chose not to immunise their children against this particular illness, and a similar scare story occurred with whooping cough. So as a result of that scare story, less people vaccinated their children, and those children grew up without the immunity they could have had. And as a result, if one individual who was not immune got whooping cough or measles, mumps and rubella, they're more likely to come into contact with somebody else who doesn't have immunity and could pass that illness on. As a result, cases of the disease went up again. But luckily, people realise that the disease itself is much worse than the side effects, and people begin to take up that vaccine again. And as a result, we get that herd immunity back where the majority of people are immune, and it's less likely that the illness gets passed from person to person, and cases of the disease will start to go down again. In your biology exam, it's very likely that you will see a question with the command term describe, which as an instruction is asking you to either recall facts, events or a process in an accurate way, or give an account of what something looks like or a trend in some data. In the context of this video, you could be asked to describe the role of white blood cells or describe how vaccines work. In both cases, you're recalling facts as well as a process in an accurate way. So let's have a go at these questions. Recognise antigens on the invaders. Engulf the pathogen. Produce antibodies to match the pathogen's antigens. Produce antitoxins to counteract the pathogen's toxins. So vaccines work because you're injected with dead or weakened pathogen. White blood cell makes correct antibody. When real pathogen invades, antibodies are released rapidly and in large quantities before symptoms develop